Here's another thing to look for when you're balancing chemical reactions. You want to look for polyatomic ions showing up because it's often easier to balance the polyatomics by treating them as one unit. In other words, polyatomics obviously have more than one element, and in the previous examples we've been balancing each element individually. For a problem like this next one, when I see a polyatomic like this chlorate anion and this oxalate anion, C2O4, I'm going to balance those. Instead of looking at chlorine and oxygen separately, I'm going to look at how many of those polyatomics I have. So again, I'm going to start with an element that only shows up once on the left and once on the right. In this example, I have 2 titanium on the product side. I need a coefficient of 2 on the reactant side. Now I can look 1 cadmium on the left, 1 cadmium on the right. Now I can focus on the polyatomics. This coefficient of 2 tells me I have 2 of these chlorate anions. But the subscript 3 tells me there's more than just 2. I have 3 chlorate anions if I only had 1 of this molecule, but I have 2 of them. So that's a total of 6 chlorate anions. On the product side, I have a total of 2 chlorate anions. So I need to multiply by a coefficient of 3 to balance out those chlorates. I can also look at the oxalate, C2O4. I have 3 on the product side, and notice there's no parentheses on the reactant side because there's only 1 of them, and you don't use parentheses around a polyatomic unless you have more than 1. But I need a coefficient of 3 to balance out 3 of those C2O4 or oxalate anions. And notice that 3 balances my cadmium. I have 3 cadmium on the left and 3 cadmium on the right. Here's a reaction where I see the sulfate anion, SO4, 2-. I see the hydroxide anion, but I don't see a hydroxide anion on the product side. It's really there because remember, we can write water as HOH. A hydrogen paired up with the hydroxide, that's equivalent to H2O. So if I'm balancing this reaction, I would start with an element like iron, 2 on the right. I need a coefficient of 2 on the left. Then I can look at how many hydroxides I have. 2 of these molecules. Each molecule contains 3 hydroxides because of that subscript 3, so that's a total of 6 hydroxides on the left. And right now I only have 1 hydroxide on the right, so I need to make a coefficient of 6. Then I could look at the sulfate. I have 3 sulfate on the product side, only 1 sulfate on the reactant side, so I need to make the coefficient there a 3. When you balance this way, you have to keep in mind what you're balancing. This hydroxide, we have a total of 6 on the reactant side. We balance that with 6 waters. We also have the hydrogen part of the water, and that's being balanced by the hydrogen that's in front of the sulfate in sulfuric acid. So go through and count up each element and you'll see that this is still a balanced reaction, but we got to that point by treating the polyatomics as one unit. Here's another example where you can see sulfate on the left, sulfate on the right, hydroxides on the left. So I'm going to rewrite my water as HOH. And in the previous one I was balancing, I left this as 6 HOHs, but then I forgot the last step of going back to the original form of H2O. So I can rewrite this as HOH as long as I don't forget to change the coefficient in front of the water to be the same. So I would balance this one by looking at 1 aluminum on the left, 2 on the right. So I'm going to make a coefficient of 2 in front of the aluminum hydroxide. This is going to give me a total of 6 hydroxides. So I need 6 HOHs, 3 sulfates, H2SO4. We have 1 sulfate, so I need a coefficient of 3. So very similar to the last reaction, we end up with the same coefficients, 2, 3, 1, and then H2O has to be a 6.